Hi guys, welcome to Pencil College. In Chapter 12.1, we have learned about some trigo identities, and in this video, we'll be moving on to example 2 and example 3. Okay, so in example 2a, given that cosine of theta is equals to 3/5, find the possible values of cosecant theta. Okay, so let me just remind everyone that this function over here is read as cosecant. Okay, and the cosecant of theta is defined as 1 over sine theta. Okay, so to solve this problem, it will draw upon our knowledge of the ASTC diagram. If you have forgotten, please go review the video on ASTC diagram. Okay, so since the cosine of theta is a positive value, we can either be in the all quadrant or the cosine quadrant. Okay, so first let us consider the case whereby we are in the all or the first quadrant. Okay, so theta is defined, okay, as such over here, and in the all quadrant, okay, there is a very special property whereby our theta happens to be the same as our basic angle alpha. Okay, so this red angle here is alpha. Okay, so given that cosine of theta is 3/5, we all know that cosine of theta is equals to adjacent over hypotenuse. Okay, so the adjacent must be 3 and the hypotenuse must be 5. Okay, since it's 3/5. Okay, so using Pythagoras theorem, we can solve that this side over here, which is the opposite side to theta, is just 4. Okay, so in the first scenario, okay, the sine of theta is actually equals to opposite, which is 4, over hypotenuse, which is 5. Okay, and it's a positive value because we are in the all quadrant. Okay, so in the first scenario, the cosecant of theta is defined as 1 over sine theta, okay, which is 1 over 4/5. Okay, and pressing this into your calculator, you just get a positive 5 over 4. Okay, however, we're not done yet, okay, because there is another scenario to consider, okay, which is this one over here. Okay, whereby theta falls in the cosine quadrant. Okay, so to do this example, let me use a different color. Okay, so for theta to be in the cosine quadrant, theta will be measured from here all the way till here. Okay, so this is my theta, and I will draw my right angle triangle, and then I will move on to identify my basic angle alpha. Okay, so alpha is always measured with respect to the x-axis. Okay, and this is my alpha. Okay, so similar to the first scenario which we did previously, okay, let me first identify the lengths of my sides. Okay, so cosine of theta is 3/5, so the adjacent would be 3, okay, which is this 3 over here, which happens to be the same, and then the hypotenuse is 5. Okay, using Pythagoras theorem, we can work out the length of this side to be 4. Okay, however, we will indicate on this diagram as a -4 because we are moving downwards, okay, from the y-axis. Okay, so we are moving downwards, so downwards, okay, from the y-axis, therefore it's a -4. Okay, it's not a +4. Okay, so I will move on to evaluate cosecant theta. Okay, so cosecant theta is defined as 1 over sine of theta. Okay, and in this case, the sine of theta is opposite, which is -4 over hypotenuse, which is a +5. Okay, so -4 over +5. Okay, so pressing this in our calculator, we'll just get -5 over 4. Okay, therefore there are two scenarios to consider for this example. Okay, let's move on to example 2b. Okay, so let us first read the question. So given that cosine of theta is equals to 3/5, find the possible values of cotangent theta. Okay, so since the cosine of theta is a positive value, okay, so this value here is a positive value, we can either be in the all quadrant or the cosine quadrant. Okay, so let us first consider the scenario whereby we're in the all quadrant. Okay, so theta will be measured in this direction. Okay, so this is my theta, and let me draw my right angled triangle, and also let me identify my basic angle alpha. Okay, so alpha is over here. Okay, so this is alpha. Okay, so since cosine theta is 3/5, okay, the adjacent must be 3 and the hypotenuse must be 5. Using Pythagoras theorem, we can find that this side is 4. Okay? Okay, so recall that the cotangent of theta is defined as cosine theta over sine theta, or we can write it as 1 over tangent theta. Okay, so in the first scenario, cotangent theta, okay, for some of you, you might want to write it as as such, cot theta. Okay, both are the same. Okay, cotangent theta is a slightly, cot theta is a slightly shorter form. Okay, so this is actually 1 over tangent theta, and from our diagram we identify tangent theta to be opposite, which is 4, over adjacent, which is 3. Okay, and pressing this in our calculator, we'll just get a positive 3/4. Okay, how about the second scenario? So let me use a different color for the second scenario. So theta will be measured from here all the way into the cosine quadrant. Okay, so let me just draw in my right angled triangle. So in this case, this blue angle is my theta. And then for alpha is this angle over here. So this is my alpha. Okay, so what will I do next? I will fill in the sides, or the length of the sides of this right angled triangle that I've just drawn. Okay, so the cosine of theta is 3/5. So adjacent would be 3. Okay, so it's the same, 3. And then the hypotenuse will be 5. Okay, over here. Now, similar to the previous example, using Pythagoras theorem, we can work this out to be 4. But since we are moving downwards along the y-axis, okay, I will identify this side to be a negative 4 units. Okay, so the cotangent, of theta is equals to 1 over tangent theta. Okay, and the tangent theta is defined as opposite. So in this case, my opposite is negative 4. Okay, negative 4 over adjacent, which is a positive 3. Okay, so pressing this into my calculator, I'll just get negative 3/4. Okay, I hope you enjoyed this video. For more videos, please log on to pencilcollege.com. See ya!